You all might know it from your personal devices as you use it in your car, for example. You want to connect your personal mobile phone with your car, for example, with Android Auto or with the CarPlay. And you just start the application and information will be exchanged. And this basically only works because there is a common communication technology, in this case, Bluetooth, and it's already standardized what kind of data will be exchanged. For example, the address book or the maps information or some information from the cell phone will be exchanged with the car. And this is basically the idea, which should also be available in production environment or shop floor environment, where you have a standardized communication architecture and a standardized vocabulary, so a standardized or defined information to be exchanged. Now, currently, in many shop floors, in many production environments, the situation is very heterogeneous. So we have different devices, different machines, all using different protocols, making it difficult to exchange information. So the goal is that we aim for to have a global production language based on OPC UA with companion specifications to have a common communication between different devices as we know it from other devices as well. So now, how is this idea built up? As I said, currently we have the mostly proprietary communication between two devices, for example, using proprietary protocols. So you have to define the interface for exchanging the information each time when you want to add another device, and so on. And this is where it began, where the mechanical and plant engineering industry had several requirements for a open standard to be used as a communication architecture for a standardized interface. And this requirements they had basically matched only with the OPC UA technology. And basically those requirements are shown on the right side, why OPC UA was chosen for the standardized communication architecture. First, it is an open source technology. It has a built-in security. So as an example here, the Federal Office in Germany for Information Security also tested it. So it's a secure communication architecture, communication technology. The standard should support various protocols, and OPC UA supports different protocols as, for example, MQTT. So important to keep in mind, OPC UA itself isn't a protocol, but it supports different protocols. And it should cover semantic machine descriptions that we will have a look later on at the further slides when we come to the companion specification. But the semantic machine description means the definition of each data or each information coming from the machine. And important, the scalability, that the communication architecture can be used for communication between machines, but also from machine to component, and also in the other direction, machine to higher level systems as MES systems or to cloud environments. So this is why basically OPC UA was the only technology matching all those requirements, which is why the industry from mechanical and plant engineering decided to go with this technology as standardized communication architecture. And basically, it is built up in two layers. We have on the bottom here the transport layer and additional the information layer. And as I said, we have the support of different protocols. So how the information will be exchanged. And then OPC UA supports two different communication mechanisms. On the one hand, the client-server mechanism. So as you know it maybe from sending a letter and receiving back the answer that the letter has arrived, for example. So sending an information, getting an answer back is the client-server mechanism. And also, on the other hand, the publish-subscribe mechanism, imagine as, for example, a radio sending on a specific frequency. Many participants can subscribe to the frequency and get the information, but the sender does not get any information back. So those are basically the two different communication mechanisms supported within the OPC UA. And so there are different uses within a production environment or shop floor environment using the different mechanisms. And the information layer basically is built up on, of course, the OPC UA meta model to define how the information models within the OPC UA framework should be done. There are already some built-in information models for, say, general information as alarms, conditions, and so on. And then we have, as I said, the semantic machine description, which is quite important. And those are the OPC UA companion specifications. And for domains from the mechanical and plant engineering, the OPC UA companion specifications are built up within industrial working groups within our association from the VDMA. And those companion specifications contain the information models, so the definition of each information from a machine tool, from a woodworking machine, so from different domains. And those are all the information which the working group, consisting of different industrial partners, defined as the basic information for a specific machine type. But if there's a vendor saying, okay, my machine has more relevant information and maybe some information which is also makes the difference between him and another machine builder, a competitor, for example, then there's the option of extending the information model by the vendor-specific extensions. So the standard, the companion specification, every time is the minimum, and each vendor can extend the information model on his specific information he wants to have in the information model. So now it starts again. Yeah. So coming back to our different levels of interoperability, we have now the communication architecture. So thinking of an analogy of a language, here the grammar is defined, how we will exchange the information. And with the OPC UA companion specifications, the vocabulary of a language, to stick with those analogy, is defined. So what information will be exchanged? And just to give you an idea from the different trade associations within the VDMA, there are already several domains, for example, additive manufacturing or machine tools, robotics, which already defined or are currently in the process of defining their domain-specific companion specifications. So with this, we have the vocabulary from the different domains. But over the time, one realized that each domain-specific companion specification has information in common with others. And those information were independent from the specific domain. So they were basically cross-domain information. And this is why the OPC UA machinery as a basic specification or a cross-domain and harmonized specification was built up. And to give you some examples, what is covered within the OPC UA for machinery, as I said, those are information which are independent from the specific domain. And those information are covering use cases, as you can see on the right, for example, machine identification or the machinery state. Stick with this example. Machinery state just gives you the information. Is your machine currently running? Is it switched on, switched off? This kind of information. And this is independent from a domain. It does not matter if it's a machine tool, a woodworking machine, or industrial robot. No? So all those use cases are covered within the OPC UA for machinery. And as you can imagine, as a cross-domain and harmonized specification, it is quite huge. And this is why it is published in building blocks. And each building block is regarding a use case. So each use case we can see here is a building block which can be implemented and used. Upcoming building blocks from the OPC UA machinery are the basic server structure, for example, or also nowadays a common topic regarding the energy management, which is also independent from a specific domain. And with this example, I want to show you how those specifications work together. So we have on the bottom the OPC UA for machinery as the basic companion specification for the whole mechanical and plant engineering. And this can be, there you can add each companion specification depending on your domain. So if you're from the domain of the machine tools, then you build on top the OPC UA for machine tools, and you can specify a bit further with a companion specification for laser machines. Or other example, you can combine the OPC UA for machinery with the companion specification for woodworking machines. And then you have all the information standardized, so your vocabulary standardized for information exchange. And to give you an example, what is the benefit of having the common language, the common vocabulary? I will pick the example of machinery state. As I told you before, the information in which state your machine currently is. Before the companion specification of, or the building block of machinery state, each machine of a domain had different definitions for the same state. One says working, the other says running, one says production. Each mean the same, but the definition is different. Makes it impossible to have a communication between two systems. You always have to map the meaning. And with the building block for machinery state, which to give you an example, it needed around 2 years after the building block could be published, because there was many discussions between the different stakeholders from the industry. But they together made it to define 4 basic states. Those 4 basic states you can see here: not available, out of service, not executing, executing. And with those 4 states, each device, does not matter from which domain, can exchange the information provided in the same way, in the same language, in which kind of state they are. And now if you have a heterogeneous shop floor or production environment, you now know from each device if it is executing or not executing, out of service or not available. And to give you an example, why this is useful, only by knowing those basic information. If you have a machine, for example here, a machine for filling up bottles, and you have the signal, there's an error. Then you're looking, where is the error? And then you have the different components. You have the conveyor, the injection, and the gripper. And now by knowing from each component their different states, then you see the conveyor is on hold, the injection is on hold, and the error is within the gripper. So you easily can find the problem within your production line, and just by knowing the machine state in a common sense. And another benefit could be the overall equipment efficiency calculation, just by knowing the different machine states in your production environment over your planned production time. And then you know one day your availability was 80% from I don't know, planned 8 hours of working time, for example. Yeah, so it's just a easy calculation you have to add because you have already the standardized data and the data exchange. And with this, I just want to give you an idea of how many companion specifications already are published, are available. So it's a long list already from different domains. And those bold ones here are the building blocks from the basic specification OPC UA for machinery. The basic building blocks, process values, job management, and result transfer. And we have a list waiting to be released soon, so the upcoming ones. And as I said, it's an open standard, so they are free for download and free for implementing. And just to give you some outlook ideas where in future this could also be helpful to have your standardized information from the shop floor to be used, for example, when in future there's a product carbon footprint to be calculated. You need the information from your machines, for example, the energy consumption of a device. Or as I told you before, overall equipment efficiency calculation. Currently, we have the European Data Act, a new regulation from the European Union, which basically forces producers of connected products to provide the access to the data, which is generated during the use of the product, to the user of the product. And this basically underlines the use of such interoperability interfaces as here OPC UA with companion specifications. So there are many use cases which it could be useful to have the standardized interoperability interface. So to sum up here, the data is the key for the Industry 4.0 use cases, and the usage of the OPC UA companion specifications, they provide a secure, easily and accessible self-evident data. And a good starting point, as I told you, is the OPC UA for machinery, because you also can use it if there isn't yet a domain-specific companion specification for your domain. So if you have a machine and don't find a companion specification which fits your domain, your machine, you also can start with the OPC UA for machinery and already covering 70 to 80% of the data or the information which is relevant to be exchanged. And as those are open standards, they are free of charge and can be used by everyone. So I thank you now for the attention, and I give further to Eric.
Okay. Okay, so hopefully you can see my screen and you can hear me, which is always good.
Yes.
Okay, so what I thought I'd do is I would talk you through how we're using OPC UA inside our SmartDFE product. But before I talk about the OPC UA side of things, I just probably wanted to show you what the DFE is, what the SmartDFE is. So the SmartDFE is a digital front end. It was really focused on one sector of the market, single pass roll-to-roll inkjet, inkjet and hybrid presses, inkjet and say Flexo. It was aimed at that market because we were going after very, very high speed ripping. But it can be used for other markets, including things like industrial type applications. It was built to allow our OEMs to get into the market very quickly. So if you don't have a large software department, you can get to market quickly with a turnkey white labeled solution. But then you need to be able to expand and build on top of that so that you get your own value with your own press into market rather than having a black box that's shipped with everybody's presses. So we wanted to be able to allow you to innovate and extend the product. And we also wanted to be fully automated, fit into a fully automated manufacturing system where press might be one part or a printing subsystem might be one part of the process, but then have it plug into that system, the whole factory, if you like, and have it as another component in the overall manufacturing process. And we wanted to also support things like Industry 4.0. So just a really brief tour. I won't dwell on this too much because we want to get to the OPC stuff. But on the right-hand side, you'll see hopefully this is switching for you. Maximilian, can you see the SmartDFE component slide? Is that up? Yeah, cool.
Yes.
So on the right-hand side, we have a series of inkjet heads. And we have a company inside the group that's called Meteor Inkjet, who build electronics to drive those inkjet heads, and they specialize in electronics that can drive many different kinds of inkjet heads with a very simple sort of plug and play mechanism. We then have a series of RIPs which generate data for the data path, and we focus on delivering data directly to the electronics rather than going down to a file. So we rip and stream at the same time as you're printing. That's then all controlled by what we call our smart print controller. And that's a front end that the press operator uses to control the overall press. It has things like queues and controls and sets up all the different RIPs and communicates with Meteor, that kind of thing. We also communicate with other electronics, but Meteor is the one that's inside the group. And then there's a smart quality product, which basically allows the SmartDFE to get set up for any particular media, ink, and configuration, and make sure that you get good quality out of that. And we'll talk a little bit about that in future slides. The smart control system uses OPC UA, and this is where we'll start to talk about it, to allow you to get access to all the data that's in the SmartDFE for remote monitoring, connection to smart factories, and also getting data up into the cloud. And then I'll talk a lot less about the other component. Smart performance is really an AI-based system to allow you to maximize the data throughput and keep up with the press for the different kinds of PDFs. And then we have a full workflow suite in front of that for creating the PDF that you will use to print with. So creating the one-up and then creating the N-up, effectively the imposed job and all that kind of thing, and also connect up to business systems like MIS and ERP systems. So that's the overall collection of products, components that make up the SmartDFE. But what we want to do today is focus on the smart connectivity side of things. So why did we choose OPC UA? So on a digital press, rather than say a flexo press, the RIP and the DFE is really an integral part of the press. It's not something that sits in a separate room and generates rasters, which are then generated into plates and then used on the actual device. It is an integral part of the actual device, the printing device. So it's not a separate box. We wanted to be able to have a DFE that allowed you to build your own DFE if you wanted to. Build your own front end. Maybe you want something not as complex as what we supplied. You only need a certain amount of it. Maybe you just want one green button that starts and stops the press and everything else is just automatic. But you get to choose what that UI, that front end looks like. We wanted something where people could use existing knowledge. And we found that when we started to talk to our OEMs about OPC, they actually were familiar with it because they were using it to interface with their PLC, for instance, that was the heart of the control for the press. So there wasn't something they were, it was unusual to them, but it was something that perhaps the extent of what they could do with it was something that they hadn't thought of. We wanted to be able to seamlessly connect to components within the press. So, ink delivery systems, for instance, and external components or the web. So we needed something that would allow us to go down into the device or out to the outside world. And for that meant if it went to the outside world, we needed to ensure secure communication, and that's part of the OPC specification. One of the challenges when you build a platform to allow people to build things on is that there's a barrier to the first set of people building components that build on top of that platform. Nobody wants to be the first one, and therefore, getting somebody to actually invest in a proprietary or a semi-proprietary platform, or even if it's open, get them to build into that is very hard initially. Until you've got a set number of people who've already integrated with it, it's very difficult to build an ecosystem of suppliers and people that can help with that platform. But by using OPC UA, we have a ready built ecosystem of partners. There's 800 companies in the OPC Foundation, probably more now. That's the last time I checked. So, and the big companies, there are lots of people that have familiarity with OPC UA. So that gave us a ready-made ecosystem to start with. And we wanted to be standardized and an open platform. One of the best ways to get an industry to grow is to allow people to use the components that make sense to them. You don't want them locked into your component. You want to be able to allow them to choose the right component. Now, hopefully your component's the right one, but if it isn't, maybe your component's the right one for part of it, but not another part of it. So they all need to talk together, and they all need to be standardized and open to allow the industry to innovate. And we were very definite about we needed to be in that kind of environment. So that's why we chose OPC UA. So what does it look like for us? So the first thing is we have a series of what are called OPC UA servers. So we have a series of clients that consume data, allow you to control the system. And then we have a series of servers that serve up the data, allow you to have access to control the system. So our software has a series of OPC UA servers built into the software. And there are different components that have OPC servers built in. So for instance, we have an OPC server for the meteor electronics. So anything you need to do to set up that meteor electronics or configure it or get data from it, they provide an amazing SDK and DLL, the print engine DLL, that gives you all this information. But it's in a way that you have to write the software in order to get that out. So what we've done is provide an OPC UA server with all the tags associated with that and methods to allow you to get the data out in a standard OPC UA way. And we'll show you why that's important. The smart print controller, sort of the operator panel for the press, is also OPC UA enabled. So everything you can do in the GUI has an ability to be done via the OPC UA sort of system, the server. So you can write your own equivalent of our UI, or you can write your own small part of our UI. Everything that you can do as an operator, press operator, is available via the OPC interface for you to build your own solutions on. And recently we started to extend the OPC UA server into other components. So Smart Media Manager is a quality component that allows you to do things like generate profiles, color profiles, choose the drop transitions, really tune your press for a specific quality sort of requirement. And that then generates a file which is loaded into the smart print controller to configure it. Until recently, you had to use our UI, which was very good, but it was also available to be white labeled. But our OEMs wanted to be able to build that functionality into their own solutions. So we've added an OPC UA server to that as well. So now people can integrate the Smart Media Manager into their own front ends and their own solutions. All of these tools can be minimized, so you don't have to show our GUI, and the OPC UA server will sit there and give you the ability to interact with it, but without any GUI being shown. So you can see that at the bottom, it'll minimize into the tray. If you double click on it, you'll bring it back, but you can also lock it so that you can't bring our UIs back. And then your UI becomes what the operator uses. So that's how we've used it in a number of products, but now we'll show you a bit about how the clients that we've built are leveraging the servers that we have in the individual products. So the first thing to say is it's very easy to get started with our software. You can install the Smart Print Controller and get that up and running. And then you can install another application. UA Expert is one of the applications that a third party has built to interface with OPC UA servers. So it's a client. You would find our OPC UA server, which is one of the benefits of OPC UA. You can find servers, automatically search for them. You would connect to it. It would then populate the UI like it does here. If you look at this left-hand side of the panel, you'll see actual data, actual tags and methods that are coming back from our OPC UA server. So the whole of the tree is effectively available to you to see in that window. You can then look at the data, so you can pull any one of those tags into the main view and see the data updating in real time. You can choose a method in the OPC UA tree and trigger it. So we have here a start print run. So you can trigger that, call that method, and then our software will respond to what you're calling. So as I said, all of the operator functions are now available via the OPC UA. And very quickly, you've got a third-party component now controlling the Smart Print Controller remotely, potentially across domains, that kind of thing. So that's a starting point. It's a very good debug tool as well, so because you can see all of the data. So until recently, we were writing dedicated apps that would link to parts of our system. This is before that we had the OPC UA server available. So we were kind of interfacing at a lower level in our system. Now, because we've got the OPC UA server, if we want a different function for that server, we can just build a client that will connect to it. So in a recent sort of version of the software, we exposed the job cost estimation tags via the OPC server inside Smart Print Controller. And that meant that we could build just purely an OPC UA client that is the job cost estimation front end for our product. It's literally using exactly the same OPC UA tags and methods that we expose from the Smart Print Controller. That gets hidden and is now used as a remote server, and the UI is a client effectively driving that functionality for a different use case than the main GUI, if you like. In this case, we're using it to do a job cost estimation for a salesperson in the print world that only uses job cost estimation functionality within the OPC UA server that's built into the Smart Print Controller. And we also partner with a company called Tragar, who build a simplified way of using OPC UA servers and clients in C# applications or in .NET applications. Very, very good SDK, and we'll show in a second just how simple it is to get something up and running. We had, so one of the things we wanted to be able to do was have our partners, our OEMs, build their own front ends. So we worked with VIR Softtech, who are an outsourcing company within the print industry, and potentially others, I guess, to generate a UI built on the OPC UA technology and the data that was coming from our print controller. We're .NET, but they used a Node.js technology to build a web-like front end that looked the same as our front end, but actually, and then was able to control jobs and submit jobs and start and stop the print run. But was because it was web, it could then be used on iPads and mobile devices. The important thing was that they built this within 3 weeks. So they had something that would allow you to submit jobs, start and stop the press, configure different things. And they did all of that and got it up and running within 3 weeks. And because the OPC UA server is so well standardized, gives you all the data, tells you what or each of the data points is from a data type, tells you lots of information about it. It's not something you have to learn from a sort of a schema point of view. It makes it very, very easy to interface with your software. So this slide is really showing you how easy it is to get started with writing a client for OPC UA. On the left-hand side, we've got a C# client. Really, it's a command line app that does one thing. It connects to the OPC UA server. It changes the value, and then it basically drops back out again. So it doesn't do a lot of very complex stuff, but it does one thing, connects to the server, looks at a particular value, and then drops out as well. And it will update that value over time. On the right-hand side, you've got a Python software as well, which is doing exactly the same. So you're talking about 40 lines, 30 lines of code, and you've already got yourself a client which is able to communicate and control our OPC server inside the product. And there are about 17 commercial SDKs out there that make different languages easy to work with when it comes to OPC UA, everything from ANSI through to Delphi and Java and .NET. So already there's an ecosystem of technologies that allow you to interface with it really easily by picking up one of those libraries. So we connect up to software. We have different clients for front ends. But we also wanted to connect down into devices. So in the early days of what we were doing, we worked with APS Engineering, their ink delivery system. They had a protocol, a serial protocol that they used, and they had a UI that worked with that serial protocol. So what we did was we took that serial protocol, we built a gateway using a Raspberry Pi that had an OPC UA server in it. We collected the data using their protocol and then exposed the OPC UA server to allow us to pull that data up into the product. So then we had a panel in our product that allowed you to work with their ink delivery system, start and stop it, get the temperatures back, that kind of thing, using an OPC UA server that was built into a gateway for their product. And this is one of the useful things that OPC UA has. It has a whole load of different gateways and converters that allow you to get information in one format in and out of the system. And of course, a lot of the PLCs, the standard PLCs that are in the market, are programmable logic controllers that are really the brains of your press, the thing that controls all the mechanics and the system. They also have OPC UA built into them, or have a board that allows them to communicate via OPC UA. And that's often where our print vendors start off experiencing OPC UA in their world. Also, we wanted the ability for some people, two things really. First of all, if you already have a SCADA system, a supervisory control and data acquisition system, a software that really drives and monitors industrial processes, then we wanted to be able to plug printing up into that. So you had one dashboard that perhaps is running your factory, but is also able to pull up the status of the printer and the printing process that might be integrated. But it also allows you to build a front end for your printing press potentially without necessarily doing any coding. So if you wanted to rapidly prototype something, you could do that in the SCADA software, pull the information from the OPC server, control and start and stop processes, all using a SCADA package that's a standard package. On the right-hand side, we've got an iPad which was running Ignition, the SCADA package at the bottom, and was running a show starting and stopping and monitoring the kind of virtual print press in the background. But we also used the same SCADA system to build an internal test system for the company. So what you see at the bottom is 6 SDFEs, 6 SmartDFEs running individual tests for performance. The blue ones are running an AI training circuit. That's why they're blue. The green ones are running tests on how fast we can get through jobs and how fast we can process the individual jobs on different kinds of hardware. And the gray one is offline at the moment. So you're seeing there 6 different systems all being controlled and monitored using effectively something that didn't require us to do any coding. And that screen is web-based, so we can view it anywhere in the world, and we can make sure that these systems are updating and doing the correct thing. We also wanted to make sure that we could use it using a SCADA system. So that's why we invested using the SCADA system for this test system internally. And we run it every day. There's a dashboard that all of our engineers look at pretty much every day. And then finally, I guess, the fact that you have all this data and you have it in a standardized way, standardized form, it means that you can pull that data up into the cloud. So there are a number of cloud services that are already there that monitor industrial processes. There are two key ones, AWS Sitewise and Azure IoT Operations. I think that's the latest name for them because Microsoft like to change names all the time. But effectively, there are cloud-based services that allow you to collect the data and then produce dashboards and analysis of that data. So for instance, for predictive maintenance, so you might be able to collect data from printhead temperatures over time and then be able to predict when a printhead would fail, for instance. So being able to get that data out of your press and up into the cloud allows you then to mine that information for knowledge about how the system is performing and how you can maintain it going forward. And that's all very standard, and we've got an example on the website of us pulling data up into AWS Sitewise and then graphing it and recording it in a sort of dashboard. So again, because we have OPC UA, you unlock all of this other technology that's already out there. So that was quite a whistle-stop tour, but I think we can now open for questions on both Maximilian's and my presentation, and you know, please feel free to ask any questions, and we'll try and answer them.
Yes, thank you, Max and Eric, for your presentations. I think our aim today was to give you a short insight in this technology and to tell you some benefits of this data communication standard. And if you have any questions, then you can ask now, and we also will provide our contact data afterwards. You can also contact us. And of course, this is a data communication technology which is already in the market. It's used more and more by the manufacturers of machines, of IT systems, software solutions, and this is not only restricted to one industry branch. And if you go with your technology in another industry sector, you will find OPC UA there in the future. We think this is the best solution because, for instance, because of the security, of the integrated security. Yeah. Okay, there's one question to Max. You mentioned OPC UA was a method, not a communication protocol like SNMP, GMF, etc. Can you please expand on that?
Yeah, of course. So as I told, it's not a protocol itself, because basically OPC UA combines different, let's say, puzzle parts together. So it supports different protocols. So if you make use of, I don't know, TCP, MQTT, which are protocols for transferring information, then you can use it within the framework OPC UA. You don't have to change it. So it's no new protocol coming in the row, but supporting other protocols, other existing protocols within the framework. Does this answer the question, or are there still?
Yes.
Perfect.
Thank you. Further questions so far?
Okay, if there's no more questions, I guess we can close the session, the webinar.
Yes, yes.
Thank you for attending, and hopefully you found it interesting. And please let us know if you have any questions.
Question for Eric. Are you looking to make the OPC UA solution a companion spec for presses?
Yes, yes, we would love that. I think we spent the early days learning, but we now understand that a companion spec would be the right way forward. for all the reasons that Maximilian talked about. So yes, we would do, but I think we'd like to have partners that would help us, or not help us, but work with us on that companion spec.
What we do at VDMA, we coordinate and support the standardization work, no? Because somebody must do the coordination. But to develop a standard, we need the working group, not only one company, because we want to widespread the technology in the market. No? Okay. Then, if there are no more questions, then thank you for your attention, for your interest, and hopefully we see you next time, contact you in the next time, and perhaps we will have in the future standard companion specification for digital printing, inkjet integration, or other topics in the printing industry as well, as we have in the other industry at the moment. No. Then, thank you, Eric. Thank you, Maximilian, for your contribution, and see you next time.
Thanks a lot, everybody.
Thanks.
Bye-bye.